Good morning to you all, respected sir, and all my dear friends. Today I am Nishant and I will be explaining you about chain survey components and its uses. At first, chain. It is a device which measures the distances manually and gives a reading with the accuracy of plus or minus 2 mm per meter under a tension of 8 kg. In overall length of the chain shall be accurate within plus or minus 5 mm for a 20 meter chain and within plus and minus 8 mm for a 30 meter chain. It contains tallies at regular intervals to indicate the distances. Next, we will towards wooden pegs. Wooden peg is a surveying device which is used for marking stations. Its dimensions are length 150 to 200 mm and cross section 25 mm square. Next is arrows. It also helps to mark the stations. They are made up of 4 mm diameter steel wire and length is around 400 mm. And ring is present at the end of the arrow which helps surveyor to drive it into the ground. Ranging rods. It is used for ranging. They are made up of woods. They are of 2 meter to 3 meter and has a cross section of 30 mm. They have alternate white-red or white-black bands of 200 mm. Next is ranging poles. They have the same purpose as ranging rods. The only difference between the ranging rod and ranging pole is size, as its length varies from 4 meter to 6 meter and its cross section varies from 60 mm to 100 mm. Next is offset rod. Its function is to mark the small offsets. Its construction is same as the ranging rod with minor differences. They have steel shoes and a notch on one of its side for pulling the chain. They also have holes at right angles which helps in aligning. It means when we align the ranging rods with a other particular offset rod, then we have to look through these holes so that we can get proper alignment. Then we will be latch and voids, which is the last component of chain survey. The latches and voids are generally used to mark the ends instead of ranging rods and are made up of soft wood. It also means it helps to mark. It also helps the endpoints, that is the end station. Generally, the length of latches and voids are around 1 meter. Voids also serves the same purpose as latches. A groove is made at the end of the latches and voids so that a paper can be inserted into it for proper visibility of the latches and voids. With this, the components of chain survey and its uses ends. Thank you.
Hello everyone, my name is Mohammed Safwan and today I'm going to give a presentation on the topic different types of chains used in surveying. First one. Metric chains are the most commonly used chain in India. These types of chains comes in many lengths such as 5, 10, 20 and 30 meters. Most commonly used as a 20 meter chain. Tallies are provided at every 2 meter of the chain for quick reading. Every link of this type of chain is 0.2 meter. The total length of the chain is marked on the brass handle at the ends. Center tallies has 2 teeth and tallies at the opposite sides of it have 1 tooth each. 30 meter chain have 150 links each of 0.2 meter. Tallies are provided after 25 links of 5 meter. Round brass ring is fixed after every meter. Steel band or band chain. These types of chain consist of a long, narrow strip of steel of uniform width of 12 to 16 mm and thickness of 0.3 to 0.6 mm. This chain is divided by brass studs at every 20 cm, or instead of brass studs, band chain may have graduated engraving as centimeter. For easy use and workability, band chains are wound on steel crosses or metal reels from which they can be easily unrolled. These steel bands are available in 20-meter and 30-meter length and the width of about 12 to 16 millimeter. Gunder's chain or surveyor's chain. Gunder chain comes in standard 66 feet. This chain consists of 100 links, each link being 0.66 feet or 7.92 inches. The length 66 feet is selected because it is convenient in land measurements. 10 square Gunder's chain is equal to 1 acre, 10 Gunder chains is equal to 1 furlong, and 80 Gunder chains is equal to 1 mile. Engineer's chain. This chain comes in 100 feet length. It consists of 100 links, each link being 1 feet long. At every 10 links, a brass ring or tags are provided for indication of 10 links. Readings are taken in feet and decimal. Revenue chain. The standard size of this type of chain is 33 feet. The number of links are 16, each link being 1 by 16 feet. This chain is commonly used in cadastral survey. The 5 types of chain is over. Now we'll talk about some advantages of chain survey. Chain survey is simplest and commonest method used in surveying exercises. The equipment used to conduct chain survey are very simple to use. The equipment used in chain survey can easily be replaced. For example, measuring rods can be replaced with measuring tape. This method does not involve complicated mathematical calculation. In chain survey, few people are needed to conduct the survey. Normally, chain survey team has 3 people, a booker, a leader, and a follower. Thank you.
Hello everyone, this is Gyanasagar and I am going to discuss about the different type of tapes used in surveying. There are 5 types of tapes available in surveying for linear measurements, and they are linen tape, woven metallic tape, steel tape, synthetic tape, and the invert tape. First of all, let us discuss about the linen tape in detail. The linen tape, also known as cloth tape, is a varnished strip made of closely woven linen. The width of the strip is about 12 to 16 millimeter. It is available in different lengths such as 10 meter, 20 meter, 30 meter, and 50 meter. Both the ends of the linen tape are provided with metallic handles, and the whole tape is wound in leather or metal case. Linen tapes are light in weight and easy to handle. These tapes may shrink when exposed to water and also elongate when pulled. Hence, these tapes are not suitable for accurate surveying measurements. These are generally used for measuring objects and for ordinary walks. You can see the picture of the linen tape as shown in the figure. Let us discuss about woven metallic tape. The metallic woven tape is an improved version of the linen tape. Brass or copper made wires are used as reinforcement for the linen material. Hence, it is more durable than normal linen tape. A brass ring is provided at the end of the tape, which is included in the length of the tape. These tapes are available in different lengths of 2 meter, 10 meter, 15 meter, 20 meter, 30 meter, and 50 meter. These are used for survey works such as topographical survey, where minor errors are not taken into consideration. You can see the picture of the woven metallic tape. Now let us discuss about the steel tape. A steel tape is made of steel or stainless steel. It consists of a steel strip of 6 mm to 16 mm wide. It is available in lengths of 1 meter, 5 meter, 8 meter, 10 meter, 20 meter, 30 meter, and 50 meter. Meters, decimeters, and centimeters are graduated in the steel strip. Steel tapes generally came up with the metal case with automatic winding device. The tape is withdrawn from the case by using a hand during measuring, and it is rewound into the case by just pressing button provided on the case. Steel tapes are not flexible and are suitable for measuring leveled surfaces only. They may corrode easily when exposed to moisture, and to prevent this, it should be cleaned and oiled after every use. These tapes are generally used for standardizing chains, measurements of construction works, etc. You can see the picture of a steel tape in the figure. Now let us discuss about the synthetic tape. Synthetic tapes are made of glass fibers coated with PVC. These are light in weight and flexible. They are available in lengths of 5 meter, 10 meter, 20 meter, 30 meter and 50 meter. Synthetic tapes may stretch when subjected to tension. Hence, these are not suitable for accurate surveying works. However, synthetic tapes are recommended in place of steel tapes where it is essential to take measurements in the vicinity of electric fences and railway lines, etc. Now you can see the picture of the synthetic tape. Now let us discuss about the invert tape. Invert tapes are made of an alloy which consists of 36% of nickel and 64% of steel. Invert tape contains a 6 mm wide strip and is available in different lengths of 30 meter, 50 meter and 100 meter. The coefficient of thermal expansion of invert alloy is very low. It is not affected by the changes in temperature. Hence, these tapes are used for high precision works in surveying, such as baseline measurement, triangulation surveys, etc. Invert tapes are expensive than all the other types of tapes. These tapes should be handled with care, otherwise bends or kinks may be found. The picture of an invert tape is shown.
Hello everyone, this is Shivam Das, and today I will be discussing about the suitability of chain survey, important stations and important lines used in chain survey. So let's have a brief introduction about what is chain survey. Chain survey is used in case of linear measurements. It is mostly used for small planar areas. In chain survey, the total area is divided into a number of triangles of suitable sides. The network of triangle is preferred as triangle is the most simple plane geometrical figure which can be plotted using the length of the sides. Now let's get to the part, the suitability of chain survey. Chain survey is suitable when the area to be surveyed is comparatively small in size. It is ideal when the ground is fairly level and open in small details. When the measurements can be read easily and repaired in the field itself, chain survey is mostly used. For repeated and rough uses, it is suitable. Chain survey is suitable when the formation of well-conditioned triangle is easy. Again, the method is recommended for less crowded areas and areas having less obstacles. So now let's have some idea about the important stations in chain survey. The first type is the main stations. Main station is a prominent point on the chain line, which can be either at the beginning of the chain or along the boundary line. It acts as a reference for the different intermediate lines. The second type is the tie or subsidiary stations. Stations on the main survey lines or any other survey lines are known as tie stations. These are used to fix the direction of adjacent sides of the triangle. When the triangulation is not possible, the station is used to locate their interior details. What are the important lines used in chain survey? There are three kinds of lines used in chain survey. The first is baseline. Baseline is the longest chain line in chain survey. It is used as the reference to fix the direction of other lines. It passes through the center of the field. The second type is the tie line. The tie line joins two fixed points on the chain line. The advantage of tie line appears while checking survey accuracy in locating interior details. The position of tie line should be close to some features such as paths, buildings, etc. The third type is the check line. The line joining the apex of the triangle and some fixed point on the survey line or base line is called the check line. It is used to examine the accuracy of the framework. So now let's have a graphical idea about the stations and lines in the chain survey. So this is a figure of the field work where the stations and lines are denoted by the different symbols and lines. The triangle denote the main stations, whereas the circle denotes the tie or subsidiary stations, and the base line is the dotted line which connects the two main stations diagonally, and the check line and tie lines are denoted simultaneously. Now let's have a clear idea about the lines used in chain survey. This is a figure of the field work where the sides of the triangle are denoted by the check lines and the base line and the tie line. The line AB denotes the check line, whereas the line CD denotes the base line and the side EF denotes the tie line.
Hello everyone, myself Satyan Devangan. Today I am going to talk about different methods of making offsets. So first of all, the offsets are classified according to direction and length. According to direction, it is of two types, perpendicular offsets and oblique offsets. According to length, short offsets and long offsets. Firstly, let us discuss about perpendicular offsets. The distance measured at right angles to the chain line from the objects are known as perpendicular or rectangular or right offsets such as CD as shown in the figure. Usually the offsets are perpendicular offsets. In the strict sense, an offset means a perpendicular offset. Now let's talk about oblique offsets. All offsets which are not at right angles to the main survey lines are known as oblique or tie line offsets such as CD and C as shown in the figure. When the object to be plotted is at a long distance apart from the chain line, or it is an important one such as a corner of a building, oblique offsets are taken. They are also taken to check the accuracy of right-angled offsets and to locate the position of stations in various surveys. Sometimes they help in reducing the number of main survey lines. Now, according to the length. Generally, the offsets are called short when they are less than 15 meter in length and long when their length exceeds 15 meter. The offsets should as far as possible be short ones as they are less liable to variation due to incorrect length of tape or incorrect direction than if they are long. Also, short offsets can be measured more quickly and accurately than long ones. Tie lines should be drawn to avoid long offsets. Now let us see an example. The question is, the length of the offset is 15 meter and the scale of the plan 10 meter to 1 centimeter. If the offset is laid out 3 degrees from its true direction, find the displacement of the plotted point on the paper, first bit perpendicular to the chain line and second bit parallel to the chain line. Now let's talk about the solution. Let AB be the actual length of offset which is 15 meter long and deflected by 3 degrees from its true direction. Here BC equals displacement parallel to chain line and CD equals displacement perpendicular to chain line. Now first bit CD equals AD minus AC which equals AB minus AC and is equals 15 minus 15 cos 3 degree which equals 15 whole multiplied by 1 minus cos 3 degree meter. Since the scale is 1 centimeter to 10 meter, 10 meter on the ground equals 1 centimeter on the map. Now 15 whole multiplied by 1 minus cos 3 degree on the ground equals 15 whole multiplied by 1 minus cos 3 degree divided by 10 equals 0.002 centimeter on the map. Required displacement perpendicular to chain line equals 0.002 centimeter on paper. Now second bit, BC equals AB sin 3 degree which equals 15 sin 3 degree and is equals to 0.7850 meter which is the displacement on the ground. Now displacement parallel to chain line equals 0.7850 whole divided by 10 equals 0.0785. Thank you.